Hi, it's Jeff Gorey, your principal investigator, back again today with another tutorial on the Transformer Toolkit. So let's dive right into it. Today we're going to talk about the orange colored tabs in the tool. If we were to reference our color codes tab, orange basically means ancillary calculators or side calculators. And so when we were developing the application for this project, we knew that we were going to identify some calculators that should be a standalone as sort of a miscellaneous thing or ancillary deal that may feed into bigger parts of the tool or may just help inform other parts of the tool. So that's what these orange tabs are. The first one, Calcs and Conv, stands for Calculations and Conversions. There's 3 different sections, one for conversions, one for EV calculators, and one for miscellaneous calculators and utility. The conversion, basically, Excel has a newer feature that didn't used to exist. It's a formula called convert. So I set up that convert. There's a drop down of units here for temperature. Let's say I need to convert 500 Kelvin to Fahrenheit. I would just pick the drop down, enter in the data. Again, these cells are color coded per the cell color guide as required user inputs. Then everything else where you don't have to enter is green as a calculation. So I got temperature, volume, length, and data. Taking a step back, you'll also notice there are some macro buttons in here. These are for optimizing the viewing angle of the different calculator sections. So if I click Con for conversions, it's going to optimize conversions. If I do MISCs, it's going to do the miscellaneous calculators and utilities. If I do EV, it's going to do the EV charge speeds. You'll notice the zoom in on the EV is a little bit different and it doesn't include the buttons like the other ones did. That's because if you go quarter screen here, I wanted it to be optimized to get the most out of this because there's a lot of info packed in there. So if you've got a lot of screens open, that'll help you. But so we went through the conversions section. Let's go through the miscellaneous one. I wanted to throw a quick and easy average calculator in here, so you could do different calculations quickly if you were averaging different things that you needed to use in the tool. That's just there for your convenience. Also, starting cell defaults, if you were to do a new tab, just knowing what the column width is, 8.43, and the height should be, I think, 15. That's there. Also, if you need to convert, it's a weird quirk of Excel that the column widths and the row heights are different units. And so that is just one thing that I included in here as well. Let's see. And so then the EV calculators section, this one is going to be for all things related to electric vehicles. We've got something to calculate the miles per gallon electric. Basically to do that, it's a little bit more complicated but this is a good analog. If you have the all-electric range, say it's 200 miles per battery, that's the miles per a full charge of battery, just to make the units make sense. And you have the battery capacity in kilowatt hours per battery. This is a conversion factor, which is why it's color-coded as a constant value. It can calculate the mile per gallon electric. Then you'll notice there's charge speed and charge rate. Not to get these confused, speed is the miles that you add to the battery, so the drivable miles you add per hour. This one is you can calculate by taking the battery capacity, the maximum range, let's say 200 kWh in the miles, let's say 300. It'll tell you, given those 2 pieces of data, your miles per hour that you can add. A lot of times when you're looking up that info online, it's better to use the term where it's like it can go from 10 to 80% of charge in X amount of minutes. If you're looking to try to find a kilowatt charging rate, it can be better to calculate it that way, which is why we've created the second section. It relies again on battery speed, recharge percent, and recharge time in minutes. That'll give you a kW. So some helpful calculators. And then I've got a table of constants here. This is basically just your standard charge speeds. I have noticed some non-American vehicles, they are now having level 2 charge speeds that are higher than 19.2 kW, and you'll see that on the lookup tab here. I thought that it was pretty strange, but that's just kind of what they're doing. So, you know, maybe these standards will evolve if you're using this tool many years into the future. So that's that. Let's delete this extra tab that we've added, delete that. And so moving on to our second orange tab, our second calculator tab. This is basically just to calculate the maximum EV load. So there is an input section where you would, let's say it's a Jeep Grand Cherokee. You know, I'm pulling from the lookup tab then, given this year, make, and model, the max level 2 charging speed per the spec. And then looking at charger power factor, 0.985 is a good analog. And then I'm entering then the transformer size too, just to say, you know, what percentage of the capacity of the transformer is for EVs. And then given all that info, it's calculating the EV load on the transformer. Not much of a calculation there, it's just pulling that. But I guess if you had a charger with a really bad power factor, you know, that would change this here. So it's, you know, power factor is converting from what is kilowatts to actually kVA, the actual load on the transformer that would be recognized on the utility side. And then percentage of transformer for EVs. And then if you're going into a situation where maybe someone's moving into an existing house and they're bringing all their EVs with you, you can add up a bunch of vehicles here and just really see what's going on with that transformer. In this instance, let's hope we have a bigger transformer. But that's the second tab there. The third one is panel restrictions. So this was an interesting tab. One of the people on the on our project committee talked about how they did a information campaign with their customers, encouraging them to not install 80 amp panels in their garage, which if we go to our calcs and conversions, we know that's the max amperage for 240 volt level 2 charging, which would produce a 19.2 kW load, which is very, very high. They were encouraging them to not install that 80 amp service because with a lot of these vehicles, if you're only driving, 50 to 80 miles in town every day, you don't really need to charge your EV that fast. You don't need a 19.2 kW charging speed. In fact, you could make the argument that by installing that, you're making charging expensive for everyone else on your grid by subsidizing the cost of that higher transformer size and more infrastructure. And so this is one of those ancillary tools we developed to think your way through an approach like that. Or, if a customer's coming to you and saying, hey, I don't know what service I should put in, like the super duper Tesla level 2 charger is twice as expensive. Do I need to do it? Well, you could use this calculator to tell them, maybe not. So let's start out with an 80 amp size. Let's do one of the Lucid vehicles because I know they have really high level 2 charging. Yeah, 19 kW. And then say, so if I had 80 amp service in my garage and it's I'm charging it every night for 12 hours and it's a level 2 charger, so 240 volts. The max charging speed on this vehicle can charge at is 19 kW. And so every night I'm going to add, if I were to charge at that 19.2 kW all night long, I'm going to add 340 miles of charge. I'm probably not driving 340 miles every day. And so This again is where, panel restrictions can come in to help you reduce the size of a needed transformer, or maybe even avoid a transformer upgrade. So let's make it 40 amps. Think through that. Let's see here. The max charge, let's see. So, sorry, I got a little confused there, but 40 amps, because this one has such an amazing charging rate, let's say we reduced it to 20 amps, then you start to see your mileage getting reduced. Let's try another vehicle with maybe a little less insane deal in terms of charging speed, because the Lucid cars, they're very, very cool. They're also very expensive, and that may not be sort of the average vehicle. Let's do like a Ford Silverado work truck. Yeah. So, 80 amp service for this guy. If you had 80 amp service, you're adding 421 miles every night for a 12-hour charge time. Let's say we restrict it to 40, 229. That's pretty good. That's probably pretty great. If you were to fully discharge your battery, you'd be able to get 54% fully charged. And so something to think about, just a handy ancillary tool. So that has been a quick summary of the orange colored tabs, the side calculators, and ancillary tools. I hope you found this helpful, and good luck in using the Transformer Toolkit.